looking forward to see how to change the CD of my VM. Thanks.
All right. So my name is Alexander Wels. I'm a software engineer at Red Hat, and I'm on the storage team. And normally we work on CDI, but every once in a while we go over to KubeVirt and do interesting things like hotplugging. So what is hotplugging? Well, basically, it's just adding additional resources to a virtual machine. Anybody is from a traditional virtual machine management system like KubeVirt or OpenStack. Everybody knows what it is. You just maybe your virtual machine needs more memory or more CPU or an extra network or whatever. You can just hotplug these resources into your running virtual machine without shutting it down. So we're in Kubernetes world, right? So why would we even want to hotplug? Because generally, if we want to change resources on a pod or wherever, we just kill the pod and start a new one, and we're done. There's no issue there. However, with virtual machines, it's a little bit different. You actually want to keep your virtual machines alive, usually because it's running something really important and you can't just restart it. Maybe the virtual machine takes a while to boot up and would cause a service disruption. Other reasons are maybe you want to have KubeVirt be sort of like a service provider for another Kubernetes cluster. So you can get, Kubernetes in Kubernetes. And you want to add additional resources to the nodes in the client cluster. Hotplug is relatively well understood. So what's the problem in Kubernetes? A KubeVirt VM is basically just a process running inside a pod, and that allows the VM to appear like any other pod in the cluster, and we can manage VMs just like pods. There's one problem though. Pods are immutable, so I can't just modify a pod and add additional resources. So if I want to add CPUs, I can't, because the VM gets the resources from the pod, but the pod cannot be changed. All right, well, I went ahead a little bit here, but for volumes, we sort of managed to think of a way to bypass this problem. And let me start with sort of explaining how storage works in Kubernetes, and then we'll go to the solution. So storage in Kubernetes, volumes are represented by persistent volumes, and if somebody wants to use persistent volume, they make a claim. Once the claim is being created, Kubernetes will match it up with a persistent volume, bind them together, and then when a pod wants to use the PVC, the pod is scheduled on a node, and the volume is attached to the node so that the pod can use it. So as you can see here, I have two pods running on my node. Pod 1 uses volume 1 and volume 2, and pod 2 uses volume 3. This is basic Kubernetes storage. So KubeVirt uses Kubernetes storage for their VM disk images. We a long time ago decided that we wanted to have one disk per one volume, so we could use any underlying Kubernetes APIs like snapshotting and cloning and things of that nature. Mike and Ryan talked about that a little bit earlier. And if something new gets added, like the synchronization or whatever, we don't have to re-architect our code because we can just use what Kubernetes provides. So pods are immutable. We know that when a new pod is started on a node, the volume is attached to this node, but we can't add it to a running pod. So what do we need to make sure that we can hot plug? We want to attach the volume to the node. We then somehow need to mount the volume that was attached to the node inside the Virt launcher pod. The Virt launcher pod is what's running the VM. And we want to use, standard libvirt attachment calls to do this. And we don't want to fight the KubeVirt. So it is possible for us to, outside of Kubernetes, attach the volume to a node. But then the kubelet wouldn't know that we did this, and it might want to do something with the same volume, and we're fighting. So let's not do that. Instead, let's create an attachment pod. So what's the purpose of this attachment pod? The attachment pod only purpose is to attach the volume to the node. And we make sure that the attachment pod has a strict affinity with the Virt launcher pod, so that we can guarantee that when the attachment pod is started, the volume that it uses is also attached to the node that the Virt launcher pod is run on. So we have an attachment pod. We have the kubelet has attached the volume to the node. So now what do we do? The Virt launcher pod has no permissions to do anything. Fortunately, the Virt handler has enough permissions to take the volume that was mounted on the node, look it up using the attachment pod, find the location, and then bind mount it into the Virt launcher. And it also, can ensure that all the appropriate permissions are being granted so that the Virt launcher pod can actually access it and read the volume. So that looks sort of like this. So what has happened, the attachment pod has started. The volume 3 here was attached to the node. The Virt handler then sees the attachment pod and takes the volume and bind mounts it into the Virt launcher pod that is running the VM. So at this point, the volume has been mounted inside the Virt launcher pod and can now be used by the commute process that's in the Virt launcher pod. And attaching it to the VM is at this point just calling the appropriate libvirt command. I was a little faster than I thought I would be. All right. So let's do a demo. Let me share a different screen here. All right. Question: is this big enough, or do we need to make it a little bigger? I think so. That's better. I'm not brave enough to do a live demo, so I recorded this earlier. Just to start off, I have a cluster with 2 nodes, and on the cluster I've started a VMI with a container disk. It's actually the examples. There's under the KubeVirt repo, there's an examples directory with some VMIs in there. And I'm going to create a, well, that's not good. I can't see my, no. I don't know why I didn't show the data volume YAML, but it's just a blank data volume. Oops. Make it a little bigger. Okay, so let's pause for a second here. So the blank YAML is just a data volume, and it creates a blank 5 gigabyte disk image on a local storage. It created, the name is volume hotplug, and as you can see, the phase here is wait for first consumer. So the actual disk image has not been created at this point. So let's log into the running VM just to show that there's no additional disks yet. I'm in the dev disk directory. All right, so as you can see, there's only 2 disks. One is the container disk, and the other disk is the cloud init disk. All right, so let's add the volume to the running VM. So, and it's relatively easy. Once the PR that has this add volume command to virt control, all you do is say add volume, name your VMI, and then the name of the volume. In this case, volume hotplug. All right, so here you can see, because we're in wait for first consumer, we need to create a pod that binds the PV to the node that the virt launcher is running on. So this is not the actual attachment pod yet. This is just a dummy pod to trick CDI into creating the disk. So let's, here CDI has created the importer volume. So that's actually creating the blank disk image file. All right, so the disk image file has been created, the importer pod is done, and now it's created the actual attachment pod. As you can see, this is a different one from the first one. So now the disk has been attached to the running VM. So let's go back to the console. I was in /disk. As you can see, there's now a by ID directory. So let's go in there, and there we go. That's the disk that has just been hotplugged. To show that I can actually work with it, I'm going to create a file system on it by using the ID that that's in the directory I'm in right now. All right, so I have a file system created. I could mount it, but it's not really all that interesting at this point. I just wanted to show that I can actually write to the disk that was attached to the virt launcher. So let's remove it for a second. And once removed, you can see that the attachment pod was gone. As you can see, the disk is no longer in this by ID. Actually, the by ID directory is gone. It's all normal. And as you can see, if I do fdisk, the disk is not there. So let's add it again, but this time add a serial name. Sometimes it's sort of hard to find your disk inside the VM. So the serial option allows you to put a unique identifier in there to find the disk inside the VM. So just to sort of show what's happened to the running VMI, right here you'll see that a new disk was added to the VMI with a SCSI bus. That's the name, and that's the serial that we've passed into the guest. A matching data volume is added to the volume section. And somebody asked about live migration. Because this is a local storage, I can't live migrate this VM at this point. And there's a new volume status section. And in the volume status section, for any Hotplug volumes, you can see the pod that was created for attaching the status. And then the target says SDA, and right now it actually matches /dev/SDA in the guest, but there's no guarantee that the target will actually match the value inside the guest. That's why the serial is important. All right, so let's get back into the VM. As you can see, the disk is back, but now the name contains the serial number, or the serial that I added to the command. So that way I can easily find the actual disk that I added, in case I need to find it specifically with that serial number. And to demonstrate that it's the same one as I added earlier, if I try to create a file system on it again, it will say, hey, it already has a file system on it. All right. Oh, and I forgot to show that right here, it actually is an extra disk, and it's def SDA. But as I said before, it doesn't necessarily match what was reported in the volume status. All right, let's just remove it again, just to demonstrate that once it's removed, the extra volume is no longer in the YAML. So it's gone from here, it's gone from here, and it's gone from here. And that's it for the demo. Let's switch back to my presentation. All right. So what's next? So right now, even if I attach a read-write many volume, we've disabled live migration. So we're looking at adding that at some point in the near future. I actually demonstrated the wait for first consumer support. The current released version does not support this. So if you use a local storage with wait for first consumer, the odds are pretty good that CDI will create your disk on the wrong node, and it won't attach to the running VM. Hostpath is a little painful. There's some questions I see. Hostpath is a little painful because the attachment pod doesn't allow me to find the actual path of the disk image to attach or to bind mount. Also working on it, I think I found a solution for that, and hopefully that will have a PR soon. And I showed in the demo the virt control support, which does not exist right now. So right now you'll have to directly call the API, which is also somewhat painful. That's it. Questions? I got about 10 minutes. It's actually not bad. All right, so Mike Gertz asked on the Slack channel, does it only work with disk images, or you can use raw devices? You can actually use both. Raw devices are slightly more difficult for attaching because you can't actually bind mount them. But once a block device has been added to the host, I can then update the devices that are allowed in the running virt launcher container and add it that way. So block devices will actually work. And it's /dev/SDA, and the S is for because it's SCSI, yes.
Okay. Alice has the question, does the attachment pod need to be deployed in the same namespace of the Hotplug PVC or data volume?
Yes, it has to be in the same namespace as both the Virt launcher and the PVC. So you can't hotplug a PVC from a different namespace into a Virt launcher.